Naming acids. Acids are compounds that the first element is hydrogen in an aqueous or a water solution, so it means that it's been dissolved in water. There are two types of acids that we can look at. Binary acids, which are acids that have hydrogen and another element, or ternary acids that have hydrogen and a polyatomic ion. And we have to break these into two groups because each one has a unique system to name them. So binary acids. A binary acid again contains two elements. So we're going to use the prefix hydro to indicate that there's hydrogen in there. And then we name the second element and change the ending to IC, acid. So for example, HCl, you see that it has two elements, H and Cl. So we change chlorine, which is Cl, to chloric, and then put hydro in front of it. So we end up with hydrochloric acid. HI, I being iodine, we change that ending to iodic, so it's hydroiodic acid. Ternary acids all contain hydrogen and a polyatomic ion. So if we look at the polyatomic ion, that will tell us how we need to name it. So if the polyatomic ion ends in ATE, then we change that ending to IC acid. So in our example, we have HClO3. ClO3 is called chlorate. So we're going to change that ATE ending to IC, and we end up with chloric acid. You'll notice that I didn't put a hydro in front of it because had I done that, it would have been hydrochloric acid, and HCl is hydrochloric acid, not HClO3. Now, if the polyatomic ion ends in ITE, then we're going to change the ending to OUS acid. So for example, HClO2, ClO2 is chlorite, so the name would become chlorous acid. And we will never use hydro with ternary acids if they end in ATE or ITE. Now, if we need to go from the name to the formula, it's just as if we're doing something with Group A. And remember, if we see the term hydro, or if it has acid on the ending, it will always have hydrogen at the start. So if we look at this sulfuric acid, so it ends in IC, there is no hydro, so that is the sulf with the ATE ending, so this will have sulfate in it. So sulfate is SO4, 2 minus, and we have H because it said acid, and hydrogen is a +1. So when we flip our charges here, we should end up with H2SO4. Hydrofluoric acid, since it starts with hydro, it's binary. So this is going to be hydrogen. Fluoric is fluorine. So HF. F is a -1, hydrogen is a +1, so those have the same numeric number for the charge, so it would become HF.